in this question, a particle is moving along positive x direction and is retarding uniformly. So it has uniform negative acceleration, but the particle is always moving in positive direction. The particle crosses origin at time t is equals to 0 and crosses the point 4 meters at 2 seconds. We have to find the maximum speed that the particle can possess at x equals to 0 and the maximum value of retardation that the particle can have. Alright, so in this case, what we will do is, we will assume one important thing. We will assume that the particle, while moving from x equals to 0 to x equals to 4, is not changing direction. So we'll assume the motion of the particle is like this only. We are assuming this type of motion is not occurring. Particle is always moving in positive x direction. That is what we are assuming. Now, with that assumption, I can write down the displacement of the particle as a function of time. If you see, there is a formula s is equals to ut plus half at square. But there are two more formulas for this. S can also be written as u plus v by 2 into t, and s can also be written as vt minus half at square. Now, for the part A of the question, we will use this formula s is equals to u plus v by 2 into t. You have to understand that the value of s and t is given in the question. The value of s is given as 4, t is given as 2. So when we substitute, we will get 4 is equals to u plus v by 2 into 2. This gives me u plus v is equals to 4. Now, since we want the value of u to be maximum, the initial velocity we want to be maximum, so we need to have the final velocity as the minimum, and the minimum possible value of that final velocity, we will take it as 0. If this value is maximum, then this value needs to be minimum, and the minimum possible value of v, we can take it as 0, which gives us the maximum possible value of u as equal to 4 meters per second. I hope that makes sense. So answer to question number A will be 4 meters per second. Okay. Next is question B. In question B, we have to find the maximum value of retardation that the particle can have. For that, we will use the second formula, s is equals to vt minus half at square, or we will write it as s is equals to vt plus half into minus a into t square. Now once again, what we want is, we want the value of this minus a to be maximum. We want the retardation to be maximum. And if we want the retardation to be maximum, we need to have the value of this velocity as minimum. Since the minimum possible value of final velocity is 0, I can write down, therefore 4 is equals to 0 plus half into minus a times 2 square. That gives you the maximum possible value of retardation as 2 meters per second square. So answer of question B will be 2 meters per second square. I hope that makes sense.